So when going over inverse functions in calculus, one of the hardest parts is not understanding how the inverse functions work. Finding the derivative is pretty simple, but not knowing how to apply it with inverse functions can be difficult. So in order to really grasp the concept of this, we need to know how inverse functions work. So we're going to go ahead and just give like a review of inverse functions and really just like a little bit of like simpler methods than always finding and switching your x and y and solving for that. This is what I do when I do my problems, and hopefully it'll help you. So the basic concept of inverse functions is if you have your function f of x equaling y, the inverse function, which is written like this, is going to be is going to be basically like this. You're just switching your x, your original function, you're switching it the order. That is the basic concept of inverse functions. And there are ways you can prove this. So that would look like this. So in order to say that you prove it, you're going to write it as f negative 1 of f of x is going to end up canceling out to give you x. Now this works because the inverse function is basically just undoing what operation you did on x, giving you in return x. So let's kind of work on this on some problems. That way, it might not be that clear. This isn't the proper way it's written, but this is to give you an idea that the x and the y will be switching. You're going to switch the order. So I'm going to pull up a problem. So given this problem, if f of x equals x to the 5th plus x to the 3rd plus 2x minus 2, find the inverse derivative of x being 2. So this may look like a lot, but really all that this is saying right here is that we want to look for what is the derivative when we plug in 2 to the inverse. So that might be confusing, but here's one way you can look at it. So by saying that your inverse x will be 2, that's basically saying the original problem, you want the y to equal 2. So that's what that is saying. Okay, so going ahead and going to find when does this equation right here equal 2? That is just what they're asking. So if you go ahead and you plug in values, I'm going to say 1 would be the best option. So if you plug in 1, so 1 to the 5th plus 1 to the 3rd plus 2 times 1 minus 2, this will give you, sorry, I meant to put it here. So f to the 1, the function, when you plug in 1, will give you 1 plus 1 plus 2 minus 2, which is going to cancel out over here, giving you 2. So that's your x in your original function, not the inverse function, your original function. Your x will be 1, and it'll give you the y of 2. So if you have this point here on your regular function f of x, if you have this, the inverse of this will be 2, 1. This is your inverse. So this will be your inverse point. It's getting cut off there. So this is your inverse point that you're looking at. That's what the main takeaway of this is. So knowing that if you have the point 1, 2, the inverse of that will be 2, 1. So now that we have that, we can use that and get the answer. So first we need to find the derivative of f of x, which is going to be 5x to the 4th plus 3x squared plus 2. So from here, what we can do is we can plug in our 1, which is the x for the regular function, not the inverse function. So going ahead and plugging in 1, that's going to give us 5 times 1 to the 4th plus 3 times 1 squared plus 2, which is really just going to equal 10. So once we have this is our slope of f of x. But we don't want to find f of x, we want to find the inverse. So to find the inverse, what you need to do is you need to use this formula. The formula you want to use for these kinds of problems, dealing with the derivatives of inverse functions, is going to be this. The inverse derivative of x equals 1 over f prime of the inverse of x. So basically what this is telling you, and what you can get from this, is that to find this inverse derivative, you just want to use the reciprocal. Okay, so when you have f of x, and you want to find the derivative of f of x, you have, say, 10. But when you have the inverse derivative of said function, you have the reciprocal, which will be 1 over 10. So using this logic, on this equation here, in order to break this down, we can further simplify it to help us better understand it. So really what you're saying when you have this is f inverse derivative of x equals 1 over the derivative of your y. And that's because when you find the inverse of x, so when you find the inverse of x, that in your original equation, that will be your y. And this will be that value. Okay. So let's use the problem we were just working on. So we have f, the inverse derivative of 2, which is, okay, so we are going to fill in what we know because we have solved the equation. So we have 1 over f prime of inverse x. So when we found that out, we figured out that the point at f of x is 1, 2. The inverse equation is the opposite, which is 2, 1. So, using this information, your f inverse at x is basically just saying what value gives you the y value of x. We found out that to be 1. So going back to the problem, that was the value of 1 gave us this value. Well, this value here. That gave us our 2. So we're going to write the derivative. So your answer here is going to be 1 over the derivative of the function f when x equals 1, which we came out to find as 10, meaning the answer for this problem is just 1 over 10. Okay, so another thing to remember, we can use this formula here, yes, but what you're basically doing with this formula is you're just saying that slope we found for f of x, so that derivative slope we found for f at x equals 1, that was 10. The inverse of that is, the inverse of that is just simply saying when you have a y value of 1, which is the point 2, what is the derivative there, which is simply just the reciprocal of the slope of the original f of x problem. So that would be the reciprocal being 1 over 10. So that's basically what you have to do in order to solve problems like this. So we're going to go over another problem just to make sure we understand the concept, and it can be confusing at first, but once you understand, it gets a little bit simpler. But let's remember again the main takeaway, which is when you have this f of negative 1, you are saying that you have the inverse. So that's basically saying when you have f of x equaling y, your inverse is switching that. This is really what inverse is showing you. F of y equals x. It's just flipped. That's the main thing that can be confusing. So let's take another look at another way to algebraically solve it. So looking at this problem, let's take away a few things. So what do we originally want to find? We want to find what value of x in our original equation, f of x, can give us the y value of 0. Might not be too clear. Okay, so what x value can we plug in to give us a y value of 0? That is what the inverse is. So I'm gonna looking at the equation, I can see that negative 1 will suffice. So when you plug in negative 1, you will get 1/2 negative 1 cubed plus 1/2, and that's gonna be, you have 1/2 times negative 1 plus, make that more clear, plus 1/2. So that will give you 0. So we know that the x value, or third pair for this equation that we will utilize, is going to be negative 1, 0. So in the inverse, you have the point 0, negative 1, but in the original, you have the point, in f of x, you have the point negative 1, 0, and this is because of the inverse property of these equations. So using this right here, we are able to figure out what is the derivative of the inverse when x equals 0. So looking at that, we are going to first figure out what the derivative of f of x is. That's the first step. Find the derivative of f of x. We have 3 over 2x squared, and then the 1/2 is a constant, so that'll cancel out. So what we want to do is we want to figure out what is the derivative at negative 1. So that's going to be 3 over 2 negative 1 squared, giving us, right here, is going to give us just 1 times 3 over 2, giving us 3 over 2. So going to what I said, we are using, so your slope of your original equation, f of x, is going to be the reciprocal, so your inverse derivative is just going to be the reciprocal of the original function's derivative. So knowing that, the derivative will be 2 over 3. That is your final answer. The main takeaway from this is you need to just understand how an inverse equation works. So when you have f of x equaling y, inverse will be when you swap your x and you swap your y, giving you basically the function of y is equal to x. Or when rewritten, they do f negative 1 x equals y. This is the same thing. And that is what you're taking away. Know that when you find the derivative, when you find the derivative of f of x, let's just say it is 2. The inverse derivative will be the reciprocal of the value in your original function. It will be the reciprocal of the derivative in the original function. So that would make it 1 over 2. And going back to the equation, which is f negative 1 x equals 1 over f derivative f negative 1 x. This is basically telling you that reciprocal.